This video is about a doubt concerning Lorentz contraction of moving electrons in a wire. To begin with, consider a piece of uncharged wire ABCD. Here, at any portion of the wire, we have equal positive and negative charge density, which exactly cancels each other. Now let this wire be connected to the two ends of a cell, so as to make a closed circuit. In doing so, electrons start to move from one end to the other, constituting a current. And if something is moving, then there has to be the effects of Lorentz contraction, effectively increasing the linear density of the electrons moving in this wire. Purcell, in his explanation, states that, in the lab frame the conducting wire is electrically neutral. However, nothing is stated why or how this occurs. It's in fact saying, we take an uncharged wire that has equal positive and negative charge density, and on conduction, the effect of Lorentz contraction on conducting electrons takes place, increasing the linear density of negative charges, and still we have equal positive and negative charge density. Besides, there is no satisfactory third-party explanation for this, explaining why the conducting wire is uncharged in the lab frame. The thought that the effect of Lorentz contraction is universal, and that there is the effect of Lorentz contraction of conducting electrons moving in the wire, imply that the conducting wire is charged in the lab frame. If so, how charged is the wire? Why isn't it noticed physically, or why is it not measured? The possible reason could be these. The potential, at a distance r, caused by the relativistic increase in charge density of the conducting electrons, is given by the equation as shown. Now if we equate this potential to the electrostatic potential caused by a charged plastic rod which has similar potential, then it can be seen that, for example, a copper wire carrying 5 ampere current has an increase in charge density, roughly equivalent to a rod that is charged with an additional electron for every 10 meters of the rod. This kind of potential is quite negligible and can easily go unnoticed. Additionally, to make matter worse, the parts of the probes that are equidistant from the wire AB are at equipotential. Therefore, the multimeter always reads 0, and it fails to detect this potential. Moreover, there is a theoretical reassurance from the equation, F equals BQV, that, since velocity is 0, there is no magnetic force on this stationary charged particle. Which, when viewed in terms of effects of Lorentz contraction, has to imply that the conducting wire is uncharged in the lab frame, despite the effects of Lorentz contraction. This aspect is dealt with in the other part of the video, which to arrive at the same conclusion, that the wire could be charged in the lab frame. Now, believing that these could be the possible reason for the detection of zero potential, and the reason why the wire seems to be uncharged in the lab frame, since the effects of Lorentz contraction of conducting electrons is undeniable, one can expect that the conducting wire requires a net negative charge in the lab frame. So, could the conducting wire be charged in the lab frame? Requesting viewers to come to your own conclusion regarding these. Thanks for watching.